Welcome to the Padhai Karlo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Karlo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is preparing aldehydes from esters, using a controlled reducing agent to stop the reduction at exactly the right stage. Let's begin. Esters prime are genuinely less reactive toward nucleophilic reduction than acid chlorides, since the alkoxy group OR prime is a genuinely poorer leaving group than chloride. This actually turns out to be useful since it means esters require a genuinely more carefully chosen moderately powerful reducing agent to stop cleanly at the aldehyde stage without over-reduction. The strongest common reducing agent lithium aluminium hydride LiAl4 is genuinely too powerful for this specific purpose. It reduces esters completely down to primary alcohols without stopping at the aldehyde at all, since the initially formed aldehyde reacts immediate with the remaining excess hydride. This is exactly why a genuinely milder, more controlled reducing agent is essential specifically for this transformation. Diisobutyl aluminium hydride DIBAL-H provides exactly the controlled reduction needed when used at low temperature, specifically around -78 degrees Celsius, and with exactly one equivalent, or the reagent, DIBAL-H adds hydride to the esters carbonyl carbon, forming a genuinely stable tetrahedral intermediate that does not collapse to release the aldehyde at that low temperature. Instead, it holds on until an aqueous workup is deliberately performed. Only during this final aqueous hydrolysis step does the intermediate genuinely break down, releasing the aldehyde and the corresponding alcohol. Since the aldehyde is only generated at this final, controlled step, it never has the opportunity to react further with any remaining DIBAL-H, which is exactly why this specific combination of low temperature and controlled stoichiometry genuinely succeeds where LiAl4 alone fails. Across the three genuine standard routes to aldehydes, Rosenmund reduction from acid chlorides, Stephen reaction or DIBAL-H from nitriles, and DIBAL-H reduction from esters, the recurring exam theme is genuinely identical. Control the reactivity carefully enough to stop exactly at the aldehyde stage, using either a deliberately poisoned catalyst, a low reaction temperature, or a carefully limited stoichiometric amount of reagent. A frequently tested trap involves genuinely recognizing that DIBAL-H serves two distinct synthetic roles depending on the substrate, converting nitriles to aldehydes via an amine intermediate, and converting esters to aldehydes via a genuinely different tetrahedral intermediate. But in BOTH cases, the shared essential principle remains low temperature plus controlled equivalence. Also remember that if a genuinely excess or DIBAL-H, or genuinely higher temperature, is deliberately used instead, esters DO eventually reduce all the way to primary alcohols too, exactly like LiAlH4 would, so the specific controlled conditions are absolutely essential to the outcome, not merely option. Let's recap. Esters resist reduction more than acid chlorides, but LiAlH4 is still too strong, over-reducing them completely to primary alcohols. DIBAL-H, used at low temperature with exactly one equivalent, forms a stable intermediate that only releases the aldehyde upon controlled aqueous hydrolysis, preventing any further reaction. Across all three standard aldehyde synthesis routes, the shared exam theme is the same. Carefully controlled conditions are what stop the reduction exactly at the aldehyde stage. That's preparing aldehydes from esters using DIBAL-H. Keep the low temperature control stoichiometry principle sharp. It's the shared thread across every aldehyde synthesis route in this chapter. If this video helped, please like it and subscribe to Padhai Karlo for more JEE preparation content just like this. See you in the next one.